Right, today's lesson, we're going to look at the extractions and uses of metals. So where do metals come from? Well, metals come from metal ores. Now, what is a metal ore? A metal ore is a mineral or rock that contains enough of the metal to make it economically viable to extract the metal. So what that means is if I find a rock that contains 1% metal and I have to put loads of energy in to get the metal out, why would I bother? So it needs to be economically viable. Now, if a metal is very unreactive, like gold or even silver or platinum, you can just dig it up and find it in the ground. That's why the gold is so expensive. There's no need to use any extraction methods. But most other metals will have combined with oxygen and formed some sort of metal oxide, and then they will need to be extracted using various methods depending on their reactivity. So if we look at this table, this table shows us the reactivity series, first of all, most reactive to least reactive. And remember, I told you it's good to remember where the C is. So PSLC Mac Zintel, he can make some gold plates. He's the hydrogen, can manganese, silver, gold, platinum, make some gold plates. So if we start with the least reactive ones, these metals are usually found in their native form. That means they're uncombined with no oxygen, with nothing. They're just found in the Earth's crust. So you can therefore extract it by digging it. Copper, though, does come from an ore called malachite. And you don't actually need to know copper extraction for the purpose of Edexcel. For AQA, you do need to worry about copper extraction, and I'm going to make a separate lesson on that. Now, if we look at the next set, any metal below carbon can be extracted by displacement using carbon. So that means, for example, zinc oxide plus carbon will make carbon dioxide plus zinc. Okay. Now, this is called a reduction reaction and a displacement reaction, and it requires a lot of heat with the carbon. The carbon is the reducing agent. So it does use up a lot of energy, but it's cheaper than using electricity. Let me just give you an example, perhaps, of this type of reaction. 1 second. Yes, let's have a look at an example. This sheet as well, this is quite a useful one. I'll attach this as well to your notes. So this is no longer on the syllabus. It's not on AQA or Edexcel, but it can be an applied knowledge just to show you. If you take the metal oxide plus carbon, then it should either form carbon dioxide or carbon monoxide plus iron. And that's the basis of that displacement reaction. Now, this, as I said, is not in the syllabus, so you do not need to worry about it. This is just another perspective that you can look at. Okay. So these that are extracted, they have weak bonds in the compounds. These have the strongest bonds and then the hardest to extract. So if you're above carbon, you need electricity to extract it, called electrolysis. It's a topic that we have done before. So aluminium primarily is the one that's in the AQA you have to know in detail. For the purpose of Edexcel, you just need to know that the more reactive, if you're more reactive than carbon, you have to use electrolysis to separate the metal from its ore. So that's very, very expensive. It's the most expensive. So ideally, you don't want to do that. Now, in an exam, they might give you appropriate information. Then you need to decide which way you're going to reduce them. So compounds need to be reduced to produce the metal as an element on its own. So carbon is the reducing agent because it can combine with oxygen to make you carbon dioxide. Then it will leave your metal out. If the metal is more reactive than carbon, use electrolysis of the molten compounds. Do not use aqueous because aqueous will produce hydrogen because all these are above hydrogen. So in the electrolysis that we've done before, the rule was that if the metal is more reactive than hydrogen, you will get hydrogen, not the metal. So you must use the molten version, so there is no hydrogen ions. So it says details of the extraction process are not required for any of the two syllabus or syllabi. So you just need to use the table as your information point. And that's pretty much it. Just look through these, know your reactivity series, and that's how you extract the metals. I'll give you one kind of equation just to top it off. So let's do let's extract nickel. So it'll be nickel oxide will be the ore plus carbon makes carbon dioxide plus nickel. And that's it. That's how you would extract it. Now, for the purpose of AQA people and to give Edexcel people an interesting point, I'm going to show you one particular example of how you extract tungsten. So AQA people, pay attention. Edexcel people, this is just very interesting. So remember, metal oxide plus carbon and heat makes metal plus carbon dioxide, where the carbon is the reducing agent. Now, you can also use hydrogen because it's less reactive. Tungsten is less reactive than hydrogen. So tungsten is W. So tungsten oxide plus hydrogen makes tungsten plus water or steam because it's really hot. So you got a solid tungsten here that you heat up to a high temperature. You pass the hydrogen gas through and it goes out this way as steam because the hydrogen removes the oxygen from the tungsten oxide to form water / steam, and it will leave your kind of pure tungsten here. So why can't you just use carbon, you might ask? Because carbon is cheaper. Well, the problem is the carbon can actually react with the tungsten formed, because it's very hot, to form tungsten carbide. So this is just a specific point about tungsten for AQA people. For Edexcel people, it's just interesting for you to know that you can use hydrogen to displace a metal oxide. So I would definitely have a look at this. As I said, these notes will be attached. And in summary terms, metals which are more reactive than carbon cannot be extracted by reduction with carbon because they're too reactive. So we use electrolysis of the molten compound, and it's very expensive because we have to melt the metal first, and then we need a lot of electricity. Okay, that brings an end to the extraction of metals. However, for the uses of the metals, I will make a separate lesson for the Edexcel people, as they need to know these ones in particular. It's a fine line, really, because in AQA, if you look at the metals topic, you do need to know about bronze and brass and stuff like that, and different steels. But in Edexcel, they don't do brass and bronze. So I'll make separate lessons for the two syllabi for this purpose. Okay, so that's the end of this lesson. Just pick the right lesson for your syllabus for which metals you need to know the properties and uses for. Thank you, and see you next time.